In this video, I will show you how to evaluate an interesting limit, and what makes this limit interesting is that in the process of evaluating it, I will have to use not only the L'Hopital's rule, but also the Fundamental Theorem of Calculus. And to begin, let's take a look at the expression inside of the limit, and to determine the type of the limit, we would like to evaluate that expression at 1. And plugging in 1 gives us the following. And in the denominator we have 0, and in the integral from 1 to 1 is also equal to 0. So we have a 1 over 0 times 0 type of limit, which can be rewritten as 0 over 0 after manipulating the expression. Now, what I'm going to do next is I'm going to rewrite the expression inside of the limit. And next, I'm going to use the property of the limits that suggests that the limit of the product of two functions is equal to the products of the limits. As long as those limits exist. So that means I can split this limit into two, but in order for this to work, both limits must exist. So now, clearly, the limit of x as x goes to 1 exists, and it's equal to 1. And now we can focus on the second limit. And the second limit is now definitely of 0 over 0 type. And to find this limit, we're going to use the L'Hopital's rule. And the L'Hopital rule suggests that the limit of a ratio of two functions as x goes to some target value is the same as the limit of the ratio of their derivatives at that value. And that means to apply the L'Hopital's rule, I'm going to find the limit of the ratio of the derivatives of the functions in the numerator and the denominator. That means I'm going to differentiate the numerator and the denominator with respect to x. And to find the derivative of the numerator, I will have to use the Fundamental Theorem of Calculus, which says that derivative of an integral function with respect to x is simply the value of the integrand at x. And in our case, that means the derivative of the numerator is simply sine of x over x, and the derivative of the denominator is simply 1. Now we can rewrite this as sine of x over x, and this limit is not hard to find because function sine x over x is continuous at 1. So the value of this limit is just sine of 1 over 1. Since we were able to find the limit of this function, that means it was okay for us to split the limit over here. Therefore, the final answer to the question is the limit of the original function is equal to sine of 1.